With this 8 bags of gold problem, you've got some different methods of how you would solve this. In this problem, the king is asking for a way to find the cheat. And you can do that in 3 weighings. Think of it as the first method of how to do this, and that is to put bags 1, 2, 3, 4, 5, 6, 7, 8. So method number 1, to show that you can do this in 3 weighings, and that would be 4 on one side and 4 on the other. So what's going to happen is, let's say this one's heavier, this one's lighter. So there's weighing number 1. And then since we know the cheat is over here, we would take bags 1 and 2 and 3 and 4 and put them on this side. And let's say that this side was lighter and this side was, or this side was heavier, this side was lighter, so now we know the cheat's over here. Well, that's your second weighing. And then we would take these 2 and put 1 here and 2 here, and then we would know. So if this one was heavier and this one was lighter, then we knew the cheat was here. So we did that in 3 weighings. So method 2 would be how to do that in fewer ways. So one way to do that is to put, let's say 1, 2, and 3, bags 1, 2, 3, and bags 4, 5, and 6. So that means bags 7 and 8 are over here. All right, so what you've got is kind of a if-then type of problem. If it's balanced, then the cheat is over here. So that's one weighing. And if it's balanced, then you would come over here and you would weigh 7 and you would weigh 8. And if 8 was heavier, then you knew 7 was the cheat, and you were able to do that in 2 weighings. Another alternative to that is we'll put 7 and 8 over here. And here's 1, 2, and 3, 4, 5, and 6. All right, so let's say that 1, 2, and 3 was lighter. Well, that means the cheat can't be here, and it can't be here. So there's your one weigh, your first weighing. So then what would you do? Well, you've got an odd amount, so you're going to have to split that up. So let's say we'll put 1 here, we'll put 2 here, and we'll put 3 off to the side. So what if they're equal? Then we know the cheat's over here, and that would be in a second weighing. Well, what if this one's heavier and this one's lighter? Well, then that eliminates 3, it eliminates 2, and you would know that it's 1. So there it is, and how you would find that in 2 weighings. Second question is talking about a sum to 21. Sum meaning add. So one way to do this is to take your first 3, and let's just put those on the endpoints, 2, 3, and 4, which then allows you to work with 5 through 10 and think about where you would want to place those. So this could be a time where you pause the video and you try it on your own. And so then after you try this, we could see that 10 would go here, 6 could go here. That would give you 16, 16 and 5, give you your 21. So here's 7. So 9 and 5 give you 14. 14 and 7 give you the 21. And here's 8 and 7. So that's 15. 15 and 6 also give you 21. So you can also notice that the 8 and the 7, the 10 and the 6, and the 9 and the 5, those all, you got 16, 15, 14. You got 2, 3, and 4. So you can rearrange your endpoints, but that would be a way to start. is put the smaller numbers on the endpoints and fill in with your numbers on the side. Question 3, you've got a farmer that's trying to get a fox, a goose, and a can of corn or a bag of corn across the river. So here's our river. And the boat's only large enough for the farmer and one of the 3, fox, goose, can of corn. And the farmer can't leave the fox alone with the goose. Fox will eat the goose. And you can't leave the goose alone with the corn. The goose will eat the corn. So how do we get all 3 across the river? So we've got the fox, goose, and the corn. So what we'll do is we'll take the goose. So I'm going to do a lot of erasing and placing letters on either side. So we're going to move the goose from here to here. So the farmer takes the goose across the river, comes back, and is going to get the corn and bring the corn over. As soon as he brings the corn over, he's going to grab the goose and bring the goose back over to this side. So the corn is on this side of the river. Remember, we're trying to get from the left to the right, trying to get all of them across the river. So we grabbed the goose, brought it across the river. We're going to leave the goose, and we're going to bring the fox from here, from the left side to the right side. So the fox is on the right side. So once we get the fox across, we're going to leave the fox with the corn. We're going to go back, and we're going to get the goose, and we're going to bring the goose back across. So this next question says, determine a way to compute the sum of consecutive whole numbers to 100. So I'm going to start with kind of a simpler one. Let's say I have 4 numbers, and I would like to find the sum. Well, the sum would be 4 plus 3 is 7, 8, 9, 10. 10 would be the sum. So a way to, if I wanted to go with larger numbers, instead of adding them all up, I can also think about these pairs. Look at 2 and 3 and 1 and 4. So 1 plus 4 and 2 plus 3. Notice what their sum is. Their sum is 5. So I have a sum of these pairs, which would be 5 of them. Now, I also have I have 4 numbers, and in order to get 10, I would need to divide by 2, which would also allow me to think, well, if the sum of each of these pairs is 5, how many pairs do I have? Well, I actually have 2 pairs, and that still gets me 10. Okay, so again, if I had 4 numbers, I know the sum is 10. If I had 4 numbers and the sum of each of the pairs is 5, I could take 5 times 4, but I could divide it by 2. This piece right here results to 2 because you can also think, well, how many pairs of numbers I have are 2 that sum to 5, which would give me a total of 10. So if I'm thinking about 100, I have 96, 97, 98, 99, 100. So if I think about all the pairs, I could think if I take 100 101, that sum is 101. If I take 2 and 99, what's that sum? It's 101. What about 3 and 98? That's 101. 4 and 97, that's 101. So you'd always, you would narrow it down. You'd even get to the middle, and you would see that the middle would be, you've got 50 and 51. Well, what is that sum? That sum's also 101. So if you've got 101 and the sum is 101, you can also think, well, how many numbers do I have? Well, I have 100. So if I think of how many numbers I have, then I just need to divide that by 2. Or I can think, well, the sum is 101, and how many pairs do I have of 100 numbers would be 50. And so I wouldn't have to divide that by 2 on this one. And I could take 101. And so when you take 101 times 50, you're going to get 5,050. And then, of course, if you take 101, multiply it by 100, divide by 2, you're going to get the same amount. So one way of looking at this problem is whatever the number is, when we're looking at even numbers at this point with this question, it would follow suit. Figure out what the sum would be if you pair the numbers together. That would be your sum. There's your total number. And then you would divide by 2. Or you would think, what's the sum? And then how many pairs with that even number. It gets a little more complicated when you have an odd, but I wanted to look at that type of problem. With the Venn diagram, we'll look at some other Venn diagram questions later. In the Venn diagram, circle G represents integers 2 through 10. And it says inclusive, just means we're going to include 2 all the way through 10. Circle H represents the integers 6 through 12, including all of them. So how many integers are represented by the shaded region? Well, this is your overlap. Okay, this is where we're looking at which set of group numbers would be in both G and H. And we would see that 6 through 10 would fall in that intersection of those, which numbers intersect, and where you see it in G and in H. Here on this field trip, you've got 4th graders going on a field trip. There's 135 students. And then you see you've got 16 parents, and you've got 8 teachers. So let's look at everybody together, because the question says how many buses must the school order in order for this field trip. So if we add up everything, we should get 159 total people. So if we got 159 total people, we know that the bus holds 45 people. So we're kind of thinking, well, if there's 40, how many buses that seat 45 to hold 159? So if we think 3 whole buses, that's going to put us at 24 remaining. So we know we're going to have 3 full buses, and we've got 24 remaining, so there needs to be 1 more bus. So we would say 4 total buses. Question 7 is a money problem where you have an opportunity to either take in this case, take $1 million on the first day or wait 30 days and see your money grow exponentially. So in this case, you're saying, well, do you want to take $1 million now, or do you want to wait? So if you had day one, and then think of, so if I'm just looking at a table here, if I have day and the money that's earned, kind of look at it that way. Well, day one, you get that 1 penny. And then day two, it doubles. And then day three, well, that doubles. And so then we look at, well, what happens at day 10? Well, day 10, it would be 512. You go through the math on that. And then if we looked at, what about day 20? Well, day 20, you're at $524,000. Well, what about day 25? Well, day 25 is already going to put you over 16 million. And we'll look at a formula here in just a moment. And then if we look at, well, 30, some months have 30 days, some months have 31. Well, if we looked at 30 days, what would you be if it was 30-day month? Well, it would be 536,870,912. And then if you went one extra day and looked at a month with 31 days, you'd be over $1 billion. So 1,073,741,824. So obviously with this, fantasy type problem where if you could wait and have things double, it would be much larger than that 1 million. So what you're looking at is a function where you start out with 1 penny, and this is actually a geometric sequence model where we're going to double, and we're actually going to have this x minus 1. 1 times 2 to the x minus 1 power. So when we substitute in our calculator, let's say, it was 31 days, then that would put us 1 times 2 to the 30th power, which would put us actually at this number here. So that's an exponential growth problem. This handshake problem is a very good problem, and it becomes a quadratic model. When you look at the results, you've got people and you've got number of handshakes. So if we just look at some data, and if we think about it, well, if you got 1 person, you're going to have 0 handshakes. If you got 2 people, you're going to have 1 handshake. If you got 3 people, you'll end up having 3 handshakes, 4 people, 6. And sometimes it may be good to draw this out for you to see, or you can even model with your kids in class. 5 handshakes, there would be 10. And then if I kept going, 15 handshakes, if they had 15 people, would be 105. Now, if I know a formula, that can help me do this, okay? So I am going to get you to looking at a system of equation to help solve this. So when you're thinking of systems of equations, first we need to look at, well, this is going to be a quadratic model, and so ax squared plus bx is going to be our formula for a quadratic model, where C is actually going to be 0, because 1 person, it's going to be 0. So that's originally your quadratic model, but with 1 person, we should get 0 as an answer. So C would actually be 0 in this problem, all right, just knowing that this is the formula where we need to go. And so if I look at some ordered pairs over here, so I'm just going to look at 3, 3, and 5, 10. So I'm just going to substitute, this first one is going to be 3, 3. So I'm going to substitute 3 for y. I don't know a. I'm going to substitute 3 for x and square it. I don't know b, and I'm going to substitute 3 for x. So I'm actually going to get 3 equals 9a plus 3b. So I'm going to use this formula in just a moment. There's 1. 3 equals 9a plus 3b. Well, then I'm going to take, that was for this one. So now I'm going to take another ordered pair and make it 10 equals 5. And remember, I'm going to substitute 5 in for x. So just like I did at this point right here, it'll be a times 5 squared plus b times 10. And so 10 would be 5 squared is 25a plus 10 times b would be 10b. So I want to use this equation. And these two, I want to, in your systems of equations, you can use elimination. And so with that, I just need to figure out which variable I want to eliminate. And once I do that, that would give me a value for A and a value for B. So A would end up being 1/2 and B would end up being negative 1/2. So what would happen is it goes back when you do, not going to go into all the detail on that, but it would solve this equation for A and solve it for B. And so once I find what that equals, I'm just substituting back here. So what I would have is y equals 1/2 x squared plus a negative 1/2 x. And when I substitute into that equation, that x would just mean for any number of people. If I want one person, if I want 2 people, 17 people, you name it, I could substitute into this equation and find that result. Another equation where you've got 3 numbers. So what we'll say is, here's the first number, here's the second number, here's the third number. Well, the first number, it says the first number is twice the second number. Well, I don't know what the second number is, so I'm going to call it x, which means I'm going to call the first number 2x. And the third number is twice the first number. So first number is 2x, so I'm going to multiply it by 2, and I'm going to get 4x. And I know the sum is 112. So I've got 2x plus x plus 4x is all equal to 112. So that's really 1x. So 2 plus 1 is 3 plus 4. I get 7x is equal to 112. And when I solve that, I'm going to get x to be 16. Well, that's not my final answer because it says what are the numbers. So that means the second number ends up being first, second, third. The second number ends up being 16. The first number ends up being 32. And then we see the third number would be 16 times 4, which would be 64. So question 10 is asking you if you were just given the numbers 2, 7, 5, and 8. And the teacher asked the students to arrange the numbers in the boxes to create the largest sum. So students are asked to figure out, okay, how do I organize this? Well, you think about your ones place and you think about your tens place. And you're trying to generate as much as you can in the tens place. You're trying to make your number as large as you can in the tens. So you wouldn't want to put a 2 here. That'd make, and a 5, that would be 20 and 50. You want to maximize that. So we would like to put 8 and 7. Those are our largest numbers. And then 5 and 2 in the ones place. And that would generate your 157. Your next problem is when you give students something to analyze, and in this case, I gave the students a bar graph. And looking at this graph, you would ask students to create different types of questions. And you could ask the students, well, what descriptions would go along the x-axis? What descriptions would go along the y, knowing that this says birthdays in Mrs. Long's second grade class? So you could ask that question. You could also, students would create, why is there no values in June? Why do we not see a bar graph in June? Or you could say, what months do students not have birthdays? So it would just allow the students to create questions based on the end result. A lot of times we're given a graph and then we see questions. Well, here we're given the graph and we don't have questions. So we're asking the students to create different questions. Here's a website that would take you to look at different types of problems in that regard, different problem-solving types. Different types of you've got different types of graphs, bar graphs, histograms, and in this case, it would be this would be a bar graph that you would be asked to complete. And so, what you would look at is in this case, it's a survey, and she asked 25 students, and then so that total number of students would be 25. And then you're kind of looking at what the tally would be. Well, there's 0 people that watched, in fourth grade, we're collecting data, and 0 people said they watched 0 TV. Well, somebody said they watched 3 hours, 5 and 4. Somebody said they watched 9, and then 6, and then 3, and then 3, and then 1, but really nobody in this range down here. So it's kind of bunched up between 1 hour and 6 hours. So if you were going to create a bar graph, you could look at your sessions. That would go to number of hours to go to 6. So 0, 1, 2, 3, 4, 5, 6. And then here along the Y would be your frequency. So the highest one we see is 9. I'm just going to 10. And so this is just your number of hours. So what you would do is then at 1 hour, notice you've got number of hours 1. So number of hours, so just the frequency of that, we would just kind of build our bar graph. and then so forth again. So bar graphs, they shouldn't touch because there's no continuous data. I'm not asking how many watched 1.5 hours or 2.25 hours. I'm asking how many watched whole number amount of hours. And for this many fourth graders, 9 was your highest. So we would see a bar that looks like that. And then we could go to 3 hours, had 6. 1, 2, 3, 4, 5, 6. So looking somewhere here. And then at 4 hours, we had 3. And then 5 hours, we had 3. And 6 hours, we had 1. Get kind of tight on my drawing there, but I'll just go with the regular pencil. You can see now. And so there would be your bar graph showing just the frequency amount.